Welcome everyone, I'm Norman Wildberger. In this video we are going to introduce the idea of word problems in mathematics. And all the word problems that we are going to be considering are related to addition, because that's pretty well the only operation that we're on top of at this point in this series on elementary mathematics, K to 6. So we're going to practice some elementary additions in the context of sort of real life problems, which are phrased in terms of sentences, and implicit at least is the idea that the response should also be something of a sentence. So we're going to be looking at how to structure an answer to a word problem as much as how to get a solution for it. We'll be covering quite a range of problems, some very simple ones, and then some not so simple ones as we go a little bit further on into the lecture. So let's have a go. Our first problem is this one. Peter has 3 apples while Mary has 5 apples. How many do they have altogether? Well, the solution consists of identifying that the crucial quantities here are the 3 and the 5. We have 3 apples and we have 5 apples, and the question is asking us to add them together, because the question is asking how many do they have all together. That's a kind of an adding, putting things in one big pile. So we have 3 and 5 and we're adding them together. And hopefully we know by now that 3 plus 5 equals 8. Having done that computation, we can write the answer in a sentence form. We can write all together they have 8 apples. All right, our next problem. Jen has $4. This is the dollar sign. So that means $4. On her birthday, she gets $2. How much does she then have? Well, it's a question of taking the $4 and the $2 and adding them together. Because she starts with the $4 and then she adds $2 to it, in the same way that we start with a rectangle with 4 here and then add 2 more there to get one with 6. So there's the computation in terms of numbers, and here's the answer. She has $6. Notice that the equation that we write down doesn't have dollar signs in it. It's purely an equation involving numbers only. In the same way that this equation doesn't have any apples in it explicitly. It's only an equation having to do with numbers. Whether this is 3 apples plus 5 apples equals 8 apples, or whether it's 3 oranges plus 5 oranges equals 8 oranges, or whether it's $3 plus $5 equals $8, arithmetically those 3 things are all the same, captured by this single equation, which doesn't have any units in it. Afterwards, we can add the units. Similarly here, once we've made the computation, we know what the answer is 6, then the answer that we write down, we include the units. So we say she has $6, referring back to the units that the question asked us about. So this question asked us about apples, we give an answer in apples. This question asked us about dollars, we give an answer involving dollars. Our third problem has some fruit in it as well. Sue buys 7 oranges and 6 apples. How many pieces of fruit did she buy? Well, you have to know that oranges and apples are both fruit. So the question is including the oranges and the apples together. They're both fruit. So we still must calculate 7 plus 6, and hopefully we know that that's 13. But now we're talking about pieces of fruit rather than only oranges or only apples. So we might write down that she bought 13 pieces of fruit. That would be an answer. Our fourth problem. Fred walks 5 miles in the morning and 4 miles in the afternoon. How far did he walk altogether? Well, we have to add the number of miles he walked in the morning. We have to add that to the number of miles he walked in the afternoon. So it's 5 plus 4. We have to figure out what 5 plus 4 is. Now in this case, of course, it's easy. But if these were much bigger numbers, it might involve a little bit of work to actually compute what that sum is. But we're just at the elementary stages here, so 5 plus 4 equals 9. We can do that without too much problem. So there's the mathematical equation that captures the computation we're making. And once we've made that computation, we can give the answer, which is a sentence which answers the question that we're given. So Fred walked 9 miles altogether. So our next problem is this one. My holiday this year lasts a week and 4 days. How many days holiday do I have? Well, we need to add the number of days in a week and the number 4 together for the total number of days. So it's an addition question. There's a little bit of possible ambiguity in the sense of, well, what do we mean by a week here? The standard interpretation is a week has 7 days, but if you're thinking of a working week, then maybe you might only think of a 5-day week. So sometimes it's necessary for us to interpret some ambiguity that may be in a question, or maybe that we think is in a question, perhaps because we don't understand something quite as well as we like. In this case, I'm going to resolve this by deciding for myself what the week means. So I'm going to say a week has 7 days, and I'm going to write that down explicitly so that someone reading my solution can follow my train of thought. You might not agree with me that a week has 7 days. You might think, well, we're talking about a working week with 5 days. But when you read this, you can clearly see that I'm at least working under the hypothesis that a week has 7 days. So a week has 7 days. So altogether, I have 7 plus 4 equals 11 days holiday. So I'm taking the 7 days for the week, and I'm adding the 4 extra days. And then I have to make this calculation. 7 plus 4 equals 11. And I'm going to put that equation inside the sentence. That is allowable in mathematics. Okay, when we're doing mathematics or writing mathematics, we often have equations as part of our structure. So your English teacher might not entirely approve, but still in mathematics that's okay. And we will allow ourselves this insertion of an equation into a sentence. So note that I'm trying to explain what I'm doing so that someone reading it can follow my line of thinking. How many letters are in Easter Bunny? Well, I'm going to do it this way. I'm going to say, well, Easter has 6 letters. 1, 2, 3, 4, 5, 6. And Bunny, 1, 2, 3, 4, 5, Bunny has 5 letters. So altogether I need to combine 6 and 5. So altogether there are 6 plus 5 equals 11 letters. So again, note that I've inserted this equation as part of my sentence structure. So altogether there are 6 plus 5 equals 11 letters. In this case, another possible solution would be to simply have counted them to begin with. You could just count them directly and say there are 11 letters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But in this case, maybe it's a little bit more natural to look at the Easter, count those, look at the bunny, count those, and then add those up. So I hope you're getting the hang of how one might write some mathematical solutions in words. Let's have a few more examples. Our problem number 7. On Monday I scored 2 goals. On Wednesday I scored 1 goal. And on Friday I scored 4 goals. How many did I score in total during the week? So I have to look through. So on Monday I scored 2 goals. Okay, 2 is going to be important. On Wednesday I scored 1 goal. That 1 is going to be important. And on Friday I scored 4 goals. That 4 is important. So I'm going to add 2 plus 1 plus 4. Now I'm adding 3 things together. And I can combine this in a number of ways. I'm going to do the obvious and combine or add the first 2 numbers first. So the 2 plus 1 makes 3. So in the second step I'm going to write 3 plus 4. And then the last step I'm going to combine 3 and 4, add those together to get 7. Having made the computation, I'm going to write down the answer with words, and I'm going to use words for the numbers because the question that we were asked had the numbers in words as well. So I'm sort of going to reply in the same format or a similar format to the way the question was worded to me. I'll say I scored 7 goals in total. Problem number 8. Carl got $12 from his aunt, $9 from his uncle, and $3 from his sister. How much did he get in total? Well, we have to add those 3 different numbers. The 12, the 9, and the 3. So 12 plus 9 plus 3. We can combine that in either of 2 ways. We could combine the 12 and the 9 together, or the 9 and the 3 together. Let's combine the 12 and the 9 together. That makes 21. And then 3 more makes 24. And I'm going to put that all in the sentence. So since this equals 24, comma, Carl got $24 in total. The actual equation that I wrote down doesn't involve dollar signs directly. I introduce the dollar in the final answer. $24 in total, making sure that the units that I'm talking about correspond to the kinds of units that the question was asking about. Our 9th problem. If I make 3 models each week for 4 weeks, how many models have I made? Now later on we're going to learn that this is probably more naturally a multiplication question. But for now, let's just use addition. So in the first week, I make 3 models. In the next week, another 3. Then the third week, another 3. And the fourth week, another 3. So I have to add 3 plus 3 plus 3 plus 3. That 3 is for the first week. That's for the second week. That's for the third week. That's for the fourth week. And what is 3 plus 3 plus 3 plus 3? Well, that's a situation where we're talking about multiples of 3. Every time we add 3, we're going up in the chain of multiples of 3. And I remind you that the multiples of 3 go 3, 6, 9, 12, 15, 18, and so on. So the first 4, 3, 6, 9, 12. So it's nice to have some experience with the multiples, to have gone through those beforehand, so it doesn't take you too long to go read up that ladder. 3, 6, 9, 12. There are 12 altogether, so the answer, I made 12 models. Our 10th problem. At the beginning of the month, Joe had $14, while at the end of the month, he had $19. How much more did he have at the end than the beginning? So we're starting with 14. We're adding some mystery amount, and at the end we get 19. And we'd like to know what is that mystery number that we added to 14 to get 19. Well, we can kind of do it by trial and error. If we added 1, then we would have gotten 15. If we had added 2, we would have got 16. If we'd added 3, we would have got 17. 4 would have given us 18. 5 gives us 19. So the mystery number is 5. Or if you know your addition table, you know the 4 plus 5 equals 9. So that's got to be a 5. And so then now at the end, we answer the question in the same style as it's given to us. Joe had $5 more at the end of the month. Here are some comments about the problems that we've been looking at, the kinds of things that can occur, the kinds of things to watch out for. The numbers that appear in a problem are sometimes written in English, like 7 this way, and sometimes they appear in numeral form, like this. We've got to be able to work with either of them confidently. So we need to know, of course, how to convert the English names for the numbers to the numeral form. An addition problem is usually associated with adding or combining things, or finding a total, bringing things together. It's often associated with a gain or an increase. These are all words or ideas that tend to make you think you have an addition problem going on here. The essence of the solution is usually contained in a computation or a calculation, like 6 plus 7 equals 13. And it's quite reasonable to, in your solution, to actually write down that calculation explicitly. Now, for younger students, a numerical answer is enough. If you're given a very young student, you ask them, Bob had 3 apples, and then someone else gave him 4 apples. How many apples does he have altogether? The young student will just say 7. That's probably all that they will say. If they write something down, they will only write down the number 7. And that's perfectly fine for a young student. A little bit at a later stage, we can expect the student to write down the actual calculation. To write down 3 plus 4 equals 7, that equation that represents or records what was going on in their mind. They made a calculation, and we can write down on the paper what calculation we actually made. Now, older or more mature students, which is probably most of you, should write out a sentence which answers the question. So you should aspire to writing out a solution which is an English sentence, which contains the information that someone requested of you. So, for example, you can imagine this question has been given to you by your boss. You're getting an email, or you get given a memo. There's a question. You want to respond to that, not just with a number, but in a sentence form so that the person reading it can get a sense of what question this is answering. So you reflect part of the question back in the answer, which makes it easier to recognize that this answer goes with this question, where maybe this answer goes with this question. There's also the issue of the logical clarity of what we're doing. Right, in mathematics, we want to explain ourselves. We want to convey in a simple, concise way what it is that we're doing. We want to have a record of our thoughts. And these word problems are moving us in that direction. The idea of expressing ourselves logically, putting down what is necessary, but not much more than that. Here are a couple of somewhat more sophisticated problems that show us that addition and counting are often very closely connected. So a lot of counting questions where you're asked to find how many of such and such there are really in some sense addition questions, or at least they involve some addition as part of solving the problem. Have a look at this question. How many squares are in this picture right here? Well, there's one square, there's another one, there's another one, there's another one, so there's 4 little ones. And then a little bit of reflection shows that, well, actually there's the big square itself too. That's also a square. So here's what I would write down. I would explain that so that someone can follow my reasoning. I write down there are 4 little squares and 1 big one for a total of, and now I'm going to do the calculation, 4 plus 1 equals 5. So hopefully someone can read this and follow my train of thought and verify that I've actually made the calculation correctly, that I didn't add 4 and 1 and get 6. Our last problem. How many lines can be drawn which go through exactly 3 out of the points on this little diagram? There are 9 points arranged in a square, sort of a bit like this one. And now I'm interested in how many lines can be drawn through exactly 3 of these points. And by a line, I mean straight line. Okay, it's a counting question. I want to think about it systematically. So I'm going to try to group the lines into natural families. So I'm going to say, first of all, there are 3 such horizontal lines. There's one horizontal line that goes through 3. There's another horizontal line that goes through 3. There's another one. So there are 3 horizontal lines that do the trick. There are also 3 such vertical lines. That one, and that one. And that's not all. Also 2 such diagonal lines. Because this diagonal line and this diagonal line also go through 3 of the points. And I can't see any other lines, so that's all I've got. So the total is, for a total of, and now I have to add this 3, and this 2, and I'm going to write that out as an equation. 3 plus 3 plus 2, and now I'm going to make the calculation, equals 8. 3 plus 3 is 6, plus 2 is 8, and I'll just write down that 8. Okay, so that's enough for me. Now it's time for you to have a go. Here are some practice problems for you to practice not just doing a bit of addition, but also writing out concise solutions that capture your trains of thought. So here are some examples for you to practice, well, first of all, your addition skills, rather simple ones, but also, more importantly, just to interpret problems and to write out a solution using words that reflect the problem that you're asked. Okay, we're looking for a solution that briefly explains your reasoning and contains a calculation. So somewhere in it we would like to have an equation like 3 plus 4 equals 7 or something like that. And preferably your solution should be a grammatically correct sentence, beginning with a capital letter, ending with a period, reasonable grammar inside. First exercise, Joe has 13 apples and Sue has 1 more than Joe. How many do they have altogether? Question 2. Ted has $7, then his father gives him $8, then he finds $2. How much does he have? And this third question, how many rectangles are in the following figure? Same figure we've seen before, but now we're counting rectangles, not just squares. And I remind you that a square, like this one here, does also count as a rectangle. And in this exercise, how many letters in this sentence? That's maybe not even grammatically correct, is it? But anyway, let's suppose that it is. How many letters in this sentence? It's an addition question, but you have to add up quite a few things. The next one, Laura gets 8 emails on Monday, 11 on Tuesday, and 13 on Wednesday. How many did she get in total over the 3 days? And finally, Harry sleeps 8 hours a night, Monday to Thursday. So on Monday, Tuesday, Wednesday, Thursday night, he sleeps 8 hours. And 7 hours Friday to Sunday. Friday, Saturday, and Sunday, he sleeps 7. How many hours does he sleep in a week? So a chance for you to practice writing down some mathematics. In our next video, we're going to go in a slightly different direction. We'll put arithmetic aside for a little while and do some more geometry. But it will be a different kind of geometry, one that you haven't seen before. In fact, it's a geometry that most students don't see very much of. We're going to look at elementary projective geometry, which is quite a lot of fun and interesting. I hope you'll join me for that. I'm Norman Wildberger. Thanks for listening.